Welcome everybody. Just to honor time, I'm going to get started right away here. If you came to the summer symposium in the summertime in science methods, some of you know me, welcome back. If you're new and your first time today, I'll just introduce myself and who you'll be spending the next hour or so with. So my name is Nicole Lamoureux, and I have over 20 years of teaching experience in the elementary classroom setting. I served as the elementary science consultant with Edmonton Catholic School Division. I'm also very passionate about science education and some of the research for best practices, as well as in science education that have informed how this sample unit plan it was put together. So what we're going to do today and going forward, I'm just going to begin with a land acknowledgement. In the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional lands across the province of Alberta, home to many diverse First Nations, Métis, and Inuit peoples. We acknowledge that this land is a traditional meeting ground, giving voice to its original peoples and the story of creation of this country in a way that history has forgotten. So the agenda for today is I'm going to kind of talk a little bit about some of the science practices and the research behind that. Then we're going to, and then you'll do a quick overview of the document that you're going to receive today. But then what we're going to do is we're going to start unpacking it. I want you to sort of think of what today's session is me doing like a think aloud. We have an hour together, so it's kind of me walking through the planning process of how I went about integrating both matter and the scientific methods and how I went about planning. So we're going to start with curricular expectations and then connecting some of that to the background in science and the potential misconceptions. And then we'll walk through the actual lesson development itself. So I'm going to ask if you have any questions, if you can grab a pen and paper and just jot it down if it comes to you, because this is quite comprehensive. So, and a lot to get through. So I'd like to get through the resource itself and then spend, a lot of question and answer time as needed or required. Okay, so at the end of the session, you will receive the slides to this presentation, as well as a link to the planner document itself, the mini sample unit plan. And with that, it's an all-in-one planner, so there are student handouts or graphic organizers as well. I may repeat this as people might be joining in a little bit later, but all the resources will be translated into French eventually and be posted both in English and French on our ARPDC site. You will receive, in addition to that, you will receive the recording later this week or early next week as well. Okay, so the resource that was developed as well as this session slides are under what's called Creative Commons licensing. So what that really means is you're free to copy and redistribute this material in any format. You can modify, adapt, remix, transform, and build upon this material. Attribution means if you are sharing it, that you give appropriate credit, and if changes were made, that's where the share alike, that it's under the same license. It's non-commercial, meaning you can't sell it or put it on something like Teachers Pay Teachers or something like that. All right, so we're gonna kind of go through a quick overview of what you're going to receive today. So this is called a phenomena-based inquiry, and it's the What's the Matter grade 3 ice cream unit. It's gonna sound a little bit familiar, but it's gonna be a bit of a twist. There's the front matter, which is teacher background knowledge, as well as all the cusps, the learning outcome in matter. Not all the cusps from matter are in here, and I'll talk about that. But yes, all the scientific methods are connected as well. then a little bit of background. Then it kind of has a sort of a layout for you for approximate time frame. Each lesson is, one lesson can be 1 or 2 or 3 days. Most of them are 1 or 2. And then it gives your learning targets, what they're doing, and how does it connect to the phenomena. We'll talk about that. This is the layout of the lessons in the document that you will get. So you will see the objective and overview, the curricular connections, as well as the materials that are required for this lesson, any preparation that's needed, and then the procedure. And then there's sort of like a summary on the side, left side, of what sort of is happening with the students or what you're doing. So there's a lot of formative assessment and question prompts in each lesson. Okay, so a lot has changed since our previous curriculum that in science that we taught up to last year, and that was developed in 1996. Not just the fact that Beyonce is now her own singer. I say science should be the core queen bee that it is. But our things like research in developmental and cognitive psychology on how students learn in the early 2000s has sort of influenced the way in which we approach teaching and learning. If you're in the science symposium with me, I talked about PISA's definition of competencies with scientific literacy, because that is what we're developing with our students. But something else that I think connects to this is the research in the science of reading, which we've been hearing a lot about in our new curriculum with English language arts. And that is how background knowledge has a significant impact on reading comprehension. And so that question of how do we build that? Well, one of the definite areas for nonfiction text or informational text, which our students have difficulties with, is science and social studies, as well as the research in science education itself. So our science instruction and practices and resources should reflect these changes. So science is a way of thinking, and that's where the science methods come in that make it more robust, much more than it is just a body of knowledge that students should be memorizing. So it's a way of learning through thinking, which I'm going to talk about. So the key ideas through this sort of model think aloud through this sample unit plan is that how you start with the learning outcomes and cusps to identify the key concepts or science ideas in the organizing ideas, as well as the scientific methods, providing and thinking about providing authentic context for students to investigate and connect to. So familiar with their lives. We have a high percentage of ELL learners. So we'll look at that as well. The use of explore before explain in lesson development. This is something that you're going to see examples of, and I'm going to be talking about, but that came out significantly in the research, especially for accessing all learners, ELL learners or learners that struggle, giving them the opportunity, because students come with an understanding of how the world works. For example, they can throw up a ball, a child knows that it's going to come back down. What they lack is the academic vocabulary. So being strategic about when and how you introduce that. So the use of talk and vocabulary to help students make meaning of the science ideas, as well as how to triangulate evidence of student learning through formative assessment in a combination of your knowledge and skills and procedures. So let's talk about bringing our science instruction to the 21st century. So traditionally in our former curriculum and the resources that were developed at that particular time was very much an activity-based approach. So you had a learner outcome and then a series of hands-on investigations. But when students were teaching like that, and the research is coming through with that, is that were they making meaning? Were they pulling and understanding the science ideas? And that was a question I had early in my career as well. Instead, what the shift is towards is what they call sense making, or what we probably know as is making meaning. And that's looking at planning from the concept. What are the big ideas? What are the science ideas that I want my students to understand, that they have to understand in order to carry forward to the next grade? Because that's something different in this curriculum as well, is that the ideas keep building on each other, like math and language arts. So looking at using authentic science investigation to support our students. So the research in science education also looked at, what way do students learn best in science? So they looked at a group of students that did hands-on investigation only, like that activity-based, and a group of students that learned from text, like videos and articles, and then a students that did a blend of both. And what came out of the research is that students who did both hands-on investigation and then used text to support that significantly outperformed those that did either just straight activity-based learning or straight text. So what we're looking at is what was may traditionally have been with some who may feel like, oh, well-intentioned. I want my students to know what matter is. So I'm going to show a video on the 3 states of matter before they really kind of even understand what a solid is. And so some students are going to get that because what happens is in science, vocabulary is limiting to a lot of students, not just ELL. And so we're looking at shifting that for how can we use and capitalize on the fact that children come with an idea of how the world works, and then introducing or creating a context for them to investigate, then introducing the vocabulary and the terms. So what's different between a topic-driven science instruction and a phenomena-based science instruction? And you're going to see an example of that today. But for example, like in grade 3, we have erosion. Well, flipping that to something like, what caused the hoodoos near Drumheller to form this way? So, in your Earth systems, you have a lot of Alberta place locations. Well, that has to do with weathering and erosion. That gives an authentic purpose and context for the students to learn that. Or something that's familiar with their lives, like we take the bus to school the same time every day. Why is it dark at 7:15 a.m. in December and light at 7:15 in May? So that sky science kind of investigation, that prompts an investigation and sustains it, something that's over a long period of time. This kind of busy slide is kind of about how the students are taking a learning journey and making meaning. And in the research, the United States has been going through their own science reform for the last 13 years. So lots of research has been coming out of this. And what they kind of use the analogy is a storyline. There's a beginning, like you don't really know how the story is going to end. There's a middle where you're using your hands-on investigation. Then you're watching some videos, then you're reading, you do more hands-on investigation until you come to the end where you have more knowledge has been built over time that you can answer the question. Kind of like project-based learning, but there's you're doing investigation. So one of the criticisms of project-based learning is that it is too heavy on students' cognitive load. It's a lot of information to take in. So one of the things that they use to help with that is called learning summary tables. And what that is, okay, what's the phenomena or the question that we're trying to answer? These are your small scale investigations. What did we observe? What did we learn? And how does this help us answer our big question or help us understand the phenomena? And phenomena are just observable events, situations, or facts. Okay, so I'm going to show you examples of what a learning summary looks like in the classroom. The one with the picture is my own, so I have taught this way. In fact, the unit that I'm giving and modified for you, I taught in its original form in a grade 2 classroom. If you don't have room in your classroom, I know teachers talk about this a little bit, you can use a Google slide. So again, what did we observe? What did we learn? And how does this help us answer the question or understand our investigation? Or in this case, it's the ice cream phenomena or story. You don't have to use phenomena with them like our ice cream story or question. So you might be thinking, how am I going to fit this all in? That's a question I actually ask myself every year that I teach. And so something to think about with these shift is looking at the connections from our organizing ideas in English language arts and literacy. Because really, that is about communicating and receiving and understanding about ideas. We read, we write about ideas. We talk, we listen to ideas. We view and represent ideas in science and in language arts. So let's look at some connections. So science terms and vocabulary, well, we know in our organizing idea for vocabulary, it talks about tier 2 and 3 words. So tier 3 being your academic vocabulary. Our oral language organizing idea, well, you're going to see turn and talk or think, pair, shares, and whole class discussion. There is times where students are going to view videos and read text, so comprehension and text form and structures. So you absolutely need your 400 minutes, and part of that to be dedicated to developing reading and writing. But taking 15 minutes and then, really being conscious about what skills and procedures I'm pulling from language arts, adding that to your science lesson can make it more robust and allow and facilitate that time that's required. So when we look at resources in the United States, they call it materials. Resources can be a huge equalizer in the classroom, especially for students with special needs and English learners. Students are figuring things out and actually doing science rather than just being told about science. And like, this is matter, matter is this. So we'll kind of see that. So the framework I used for the planning process is from the Ambitious Science Teaching, which starts with looking at planning for engagement with important science ideas, and then getting from students their initial thoughts and ideas about the idea that they're investigating. And then the series of lessons is about supporting their ongoing thinking, changes in thinking. And because learning is a consequence of thinking. And then at the end, the students will give back to you, or during it, they'll give back to you their understanding. It says pressing for evidence. In K to 3, we say support from data from our curriculum. Okay, so I'm going to walk through the planning process now. So I gave you a precursor. So now I'm going to kind of unpack my planning process and the document that you will receive. So if we're going to plan for engagement with important science ideas, that means we need to go to our curriculum, the learning outcomes and cusps, to examine those science concepts first. So if we look here at matter and the learning outcome, it says students investigate and analyze how materials have the potential to be changed. So investigate tells you right away that that's a scientific method needs to be integrated. And students relate into investigation to building knowledge. Authentic science, that's how science works. They don't watch a video. They may do some research at strategic points, but they actually do an investigation to find out. So we want to develop that science literacy with our students as well. So let's talk about the cusps. As I mentioned, not all the cusps, the ones related to materials, natural and processed materials are meant to do later or before, and as well as the First Nation, Métis, and Inuit. So these are the cusps that are involved in this particular unit. I start with the understanding statements. Solids, liquids, and gases have distinct properties. And I look at, okay, what are we talking about with that? Well, they want them to describe them, solids and liquids and gases, states of matter in terms of properties of shape and volume. So it tells you in the curriculum, like, yes, students need to know this, but this is your parameters, that solids have a definite shape and volume. So the students are going to need to know what volume is, and that'll be worked through. A liquid is a state of matter that has a definite volume, but no shape. It takes the shape of a container, and it flows and it goes into another container as well and takes that shape. So gas doesn't have a shape or definite volume, and it flows and it's easy. And then it talks about volume as well. Now, when I go to the next cusp, I look that matter can change state if heated or cooled. So now we're looking at from liquids to solids, solids to liquids, liquids to gas. So they're going to be conducting an investigation. So these are, again, where the science methods are going to be coming in on a small scale. And then matters, now they have the definition of matter where it takes up space and has weight. I've been asked the question quite a bit about, well, really it's mass, and weight and mass are different. And then what I've been reading in the research is developmentally, students aren't ready to understand mass. Mass is the amount of matter, which is the amount of particles, or if you're looking at particles, they aren't ready for particles until grade 5 and 6 developmentally. So it wouldn't make sense to give that definition. So they're working with weight. and weight is how heavy or light an object is. And so that's kind of where that definition is coming from. Now, in grade 1, they're doing those investigations with objects. So that kind of connects. And then about the different states and freezing. Now, I don't look at evaporation or condensation because I connected that to the water cycle cusp. So the cusps are there as guides, but you are encouraged and can pull them apart to make better sense for what you're working through. Okay. So yeah, Nate, I mentioned about mass because students aren't going to understand about particle model. So at this particular level, I know it's not about confusion, but eventually they'll get to mass in grade 5 and 6. But yeah. Okay. That makes sense. So then I look at substances contained state about melting and freezing and boiling points, and then compare the melting of different substances, which is what is the matter is made of, and then the temperature at which they can go from a melting point and a freezing point. I, again, don't really get into about temperature and gas because I'm going to connect that, or I would connect that with the water cycle and evaporation. They could even do an investigation of where a puddle goes, because that is a water cycle. And that's something familiar with their lives. I look at melting and freezing as 0 degrees, as we'll see, and changes to materials and substances can be reversible and irreversible. So these are the cusps that I go through with them in the planning. So I've kind of identified it. I've moved some around. So now I'm going to go to what is the science ideas behind this on matter. And I'm going to share this with you. So we know the definition of matter, that it's made up of particles, and that's our adult definition. And it has volumes that, you know, it takes up space, has mass, and it exists in different forms: solid, liquid, and gas or plasma. In short, matter is everything except your feelings, your thoughts, love, energy, heat, light, and sound waves, gravitational, magnetic forces. So really, I like to start with matter, especially in a primary grade, because you're giving them the vocabulary to describe the world around them. And we'll talk a little bit more about that. Properties are the characteristics or features of an object, material, or matter that are observable, measurable, or both, in order to describe and understand it. So there's a purpose in getting them to describe properties and in doing that and getting familiar with doing that. So if you need to understand where your students are coming from, in grade 1, they're learning about the properties of objects. Well, that is dependent on the size of the object, and it can change. And I've bold printed the examples from our curriculum. Grade 3 and up starts looking at matter, and that is, it stays the same. It's quality or a substance will stay the same unless it's changing state, and then or a chemical change has occurred. So I look here at the examples with the bold printed for our curriculum of the properties that we examine in elementary. And now grade 2 is a bridge year because materials are similar to both the object and matter as well, because regardless of what you do, the material stays the same. And those are the properties that connect as well. So in the research, and there was actually a lot of research in matter in the United States, I'm going to highlight a few, because when you're planning, it's good to be aware of what are typical children's misconceptions around matter. Well, students often develop misconceptions that matter is something tangible, and they accept solids more as being matter than liquids or gases. So the way I've planned and some of the suggestions around this kind of helped. Many middle and high school students struggle with the notion of gases. I taught grade 6, and the fact that air is matter was really challenging, even though they went through an investigation. So I could see this as being a little bit of time in grade 3. So they often believe there is no weight to gases or air. And if you give the textbook definition of matter as anything that has weight and takes up space, it's a little help to students. It's like Teflon, it doesn't stick. So many thoughts about gases that have no weight, or they think that light and heat take up space because you can feel it. Even after instruction, they still have some difficulties in thinking that matter is whatever exists and includes all forms of energy. So what are some things we can do to address some of these misconceptions? Provide students with experiences that demonstrate the three states of matter. So that's why I plan to start with solids, then move to liquids, then move and compare the two and contrast the two, as you'll see, and then move to gas, get the definition of matter and then move to gas. You're going to see that in this particular sample unit. Have the students determine weight of seemingly what they would think as weightless materials such as gases and or powders. This came out too in the research that students don't believe that powder like flour or sugar are solids because of the definition of liquid. So we'll talk about that. Have students demonstrate what it means to take up space. What does that mean with solids and gases? So the evidence with gases about, using an air balloon to blow it up with air, some of the experiments I'm going to do or investigations will help with that as well. And then test the idea of, I like to this one, test the idea of taking up space with things that do not, like light. Does light fill the container? So these are things to confront students' misconceptions that we may be happening behind the scenes. And they said develop a rule or justify. So you're going to see something where students have to justify whether air is matter, because that gives you some insight as well. And then I teach and assess the idea of matter in multiple contexts, not just in the matter physical sciences, but connect to other organizing ideas. That was the suggestion. I think that's why I would start with matter. So if you're going to earth systems after, or living systems, because students often don't think that animals or people are matter. Oh, and that was out of order. Be aware of the definition matter is meaningless if they don't know what weight. So you have to make sure to unpack the meaning, that they know what weight means and volume means. Okay, these are the scientific methods, CUST, and which we'll kind of go through in the lesson plan itself. So if you were at the summer symposium in grade 2, the procedures for an investigation is laid out. It's not, the investigations are cyclical. So that's why I kind of created this circle. And it goes from grades 2 to 5. In grade 6, it's added on and expanded with hypothesis, because a prediction and a hypothesis are different. We don't want to confuse our students, so they're making predictions up until grade 5 inclusive. Okay, so when you're planning, you're also thinking about formative assessment, as you know. So you are scientists of your students learning. You're gathering evidence about how they are meeting the skill and procedure or demonstrating that in what they're doing. So you want to make it valid and reliable by triangulating your evidence, not focusing on just tests and quizzes, but observing them, recording that anecdotally, listening to their conversations, thinking about what do I want to hear or see from students that shows that they've met the skill or procedure that they're working on in that particular lesson. The activity is not what you're assessing the skill and procedure behind that. So what I've created and shared out with you today, and it's a forced copy, is a formative assessment checklist. So what I've done is taken all the skills and procedures. In pink is the matter skills and procedures. In green is the scientific methods for what I'm focusing on. I am teaching all of them, but this is the beginning of the year as well. So I put a red line because the rest are the remainder of them that I'll be working on later or at a different point in that organizing idea. So now we're going to look at how we would start a lesson where they would be investigating and being presented with a phenomena, which is an event, situation, or fact. So we know about making ice cream. So instead of doing it at the end, we're going to do it at the beginning. And every lesson is curricularly aligned and connected as well. This one happens to start with just the science methods, but you'll see both. So they're going to be observing on that cycle of the investigation process. They're going to be observing. So you probably will make ice cream before, have it before sitting out while you, the lesson kind of walks you through that. So the students get, a turn, they kind of gives you the, you put ice in a bag and in a Ziploc bag, and inside there's another Ziploc bag of cream with a little mixture. Anyways, they're shaking it, they take turns. The bag is closed. They don't each get a bag, it's just one bag. You can do 2 groups if you want. And there's songs they can sing, you know, they're primary, and it's all in the lesson as they're doing this, because it takes about 15 minutes or 10, 15 minutes. So the driving question for students to think about is, how does ice, which is a solid, become liquid? And how does cream, which is a liquid, become a solid? So then you want, as students are shaking it, and yes, they'll be singing a little bit, but you want them to observe, and you ask them to observe it. And then you pull them together at the end to say, okay, like, what do we notice? So before they make it, what do you notice about the cream? What do you notice about the ice cream? Because you have the ice cream made already. And so they might describe it. And then how can this cream change into ice cream? So they kind of come up with some of their ideas. And then you record that. These are different ways that you could put it down on an anchor chart. Some kids wrote it on stickies, their initial thoughts and ideas. You're going to keep that because we're going to refer back to that after. Then they actually make the ice cream, and they'll make the model. This is called models in science because scientists will they call them that anyways. And basically it's their initial thoughts. They're not going to know. The liquid cream at the beginning in the Ziploc container, the ice is down here below. So they'll draw it, and students, you know, this is kept for the end because they're going to have to refer back to this after 10, like after we made the ice cream, what was different? So they should be drawing it as heart, like ice cream, and then the sort of showing the water, how the ice cubes have melted. So this is a sample of what you see. And while they're doing that, what's provided in this lesson is formative assessment or question prompts for you to go around and ask students. So tell me about your drawing. You don't have to ask every single question on the list, but pick and choose. There's prompts here, just general ones, or if you want to see more on the picture. You're talking to me about cold, but I don't see that on your picture. How could you show cold? What crayon color could you use? So there's things there that are there to prompt, but students' thinking is going to change over time. They're not going to give you the correct answer right away, but this is like a pre-assessment for you. What do they know? Some kids know more than others and they can talk about it, and that's kind of the reason for doing this way. If somebody asked me about KWL, you know, if you ask a primary student, what do you know about matter or solids or liquids, they might not know a lot, right? Because they can't articulate it, or they might not know what you're asking about. This gives doing a model like that gives kind of an insight into some of their thinking. All right, so on the day one of lesson 2 is now they're being introduced to solids and they're observing them. So these are the properties of solids, and this is you get everything. So there's a reason I'm getting them to kind of examine these objects and materials that are different forms of solid. Your choice is to decide, you know, how, you know, they can be in groups or partners, but if you want to do both sheets, you don't have to do both, but there's a reason behind it. And again, that has to connect to misconceptions. So you can just, you know, focus on one or the other. Those are possible descriptions. It may be helpful to put up some of these words for your ELL learners. And so what they should be doing is describing. So they could say, you know, it's hard. Like, what does it feel like? Again, observational skills is using your 5 senses. How does it feel? What does it look like? You know, what can you do with it? Bumpy, bendy, you know, lots of different words are going to come up. Then they weigh it. Does it have weight? And you're just asking them to weigh it. So small scale scale that in grams. So then you have a formative assessment questions to go around and circulate and ask the group and ask students, what is a solid? How do we know if something is a solid? What is something that's the same about all the solids? That's an analyzing data. Because patterns, when patterns repeat in data, when something repeats is indicating. So for example, you know, like they seem to be, you know, staying the same, or they look the same. What are solids in our ice cream story? Getting them to think back to the question, what are the solids in our ice cream story? You know, was it the cream, the ice, like what's the solid? Getting them to think about that. You can record. This is an example of formatively assessing. So what you can do is, because we're going to be investigating and continuing to kind of think about these things, you can focus on 5 students at a time or a couple, and you can change this spreadsheet now into to met, approaching, or not met. So let's look at Elon Musk. He's struggling. So we're just focusing on solid, right? Describing solids. Elon identifies the weight of solids when describing them. He required prompting and guidance with keeping their shape. Okay, that's an example. So at the end, you pull them together and you kind of have some discussions, and they can do, like, you get some of the students to share their what they thought were solids and some of their ideas to encourage discussion. So a misconception alert about solids is they only believe that hard objects are solids. So ensure that whatever you choose has something soft like a cotton ball or plasticine or pipe cleaners. And I had briefly mentioned that flour and sugar. So kind of in thinking about that, and I have a formative assessment probe about that as well. So on day 2, what are the properties of solids that we can observe? This is when they've done explore first. Now they're going to explain, they're going to get a video that's going to give them the definition. Okay, and I'm not going to show it. It's a good video. I actually quite liked it. It is British, by the way. But what, and that's in the lesson, okay? But what I do is I don't just show videos and hope that my students understand it. Learning is a consequence of thinking. So I want to know, how are my students making meaning? So I use something called Connect Extend Challenge, and this can be, I've done this with grade 2 all the way to grade 6. So basically what Connect is information they already know. Extend is new information they learned from the video. And at the end, encouraging them to ask questions. So we'll talk about that. You can start off, if your students have never done this before, what you can do is you can ask them, what do we know about solids already? And then write down what they say. And then play the video and strategically stop at certain points. And then say, is this information we already know, or is this new information? And if they say, oh, I know this, then you can put a check mark. And if it's new information, you can write it down. Eventually in grade 3, the students were able to do this in groups. And then eventually they did it on their own. So this is something you can use and incorporate in any subject area, actually. And then challenge at the end is questions, because they should be developing questions. But questions also give you insight into ideas that they're struggling with. Students are not going to ask questions about things they already know. So they can write it on a sticky, or they can think, pair, share, and just share it out with you. Or if you know running out of time, they can talk, you can listen and write down the questions and say, you know what, I was walking around and I heard these questions, and write them down. There's a few ways of working through that. So now is the learning summary table. So this is an exemplar. The idea, this is what you could get, but the ideas should come from your students. So the activities about the properties of solids. So they did their own investigation. They watched a video and processed it. So what did we observe? Solids can be hard, round, square, different shapes. Some solids are more similar than others. Solids, what do we learn from observing that? Solids can be described and sorted by their physical properties. So you might need to prompt a little bit. Solids can look and feel different, but they have a shape. Now you want to get them to think about the shape. The video kind of talked about that, so that solids keep their shape. So you kind of want to start getting them to think about that. That's a challenge for students. And so how does this help us understand why the cream turns to ice cream, or why the ice, so when the cream turned to ice cream, it became a solid. So how does that connect, right? And I know this because it was hard, cold, and it had a definite shape. So now they're starting to connect. You're not exactly going to get something perfect like this, but you're getting them to think and make those connections back. Now, if they're ready to move forward, what are the properties of liquids that we can observe? So this is where they're going to do some exploration. So these are the liquids that they're going to be presented with. They're going to work in a small group, as you see in the picture. They're going to pour them. They're going to look at the color, the texture. And when it says, what's its shape after you pour it? Does it stay the same, or does it change? It's runny, fast, slow, free, takes the shape of the new container. Does it look like the same shape as it was in the different bottle? Like, those are things to compare and contrast. As they're doing this, again, you are formatively assessing. These are some assessment questions that you can use to gather information. How do we know if something is a liquid? In our ice cream stories, what are liquids? Well, after the ice melted, it was liquid, or the cream was a liquid. Which liquid is hardest to pour? Why? Different properties. So now they get the explanation. This is a book now that they're going to listen to. What are the properties of liquids that we can see and observe? So again, you can do a think, pair, share with the text. This book is free on Epic, or you can get it on Amazon as well. So now the same thing. The students are going to go through and do the learning summary with you. They can do a think, pair, share. What do we observe? What do we learn? And how does this help us understand the ice cream story? Well, the cream begins as liquid. I know this, like push them to tell you how they know. What data support, what did you observe that supports that? Well, the cream was filling the container. The ice turns to liquid water. So you really want to push them a little bit. Okay, so now that they've gone through solids and liquids, compare and contrast is a nice way to help them think more deeply and to distinguish about it. So basically, they can work with partners, or, and then you could have an anchor chart where they share with you after. They're going to talk about what's different about solids and liquids and what's the same. This is a formative assessment check. So this was based off for what they called a formative assessment probe, and I quite liked it. So it's kind of assessment look fors. So this is the criteria. They describe a solid, a crossed out liquid, based on the properties of shape and volume. So again, you're confronting these misconceptions and seeing if they still have them. Correctly identifies the solid in their claim, and I'll show you it, describes the properties of the object using evidence about its shape and that it's constant, it stays the same, it takes up space. And then, of course, this is analysis, so in scientific methods. So this is formative assessment. Have they met it or not yet? Okay, those are your questions. So basically, you print these off, and they can work with partners, and they're going to get claim statements. So for example, they have a choice. The rock is a solid or the rock is not a solid. And then they have sentences. I know a rock is a solid because when I observe solids, they were hard. It's keeping its shape. So you want to, push, go around and ask them about that. I know that the honey is not a solid. Okay, so things that were put in here like sugar and air is just to see where they're at with their thinking before we move on. Do they need a little bit more time? Okay, so before they go off and do this, you should co-construct what you want to hear and see from your students so they kind of have an idea. So you can say something like, how do we know when an object is a solid instead of a liquid? When talking with your partner, how do you know something is or is not a solid? What properties should I hear you talk? Oh, about this, what about, you might need to prompt them, and about taking up space and starting to introduce the word volume to them as well. When students know what the target is, they're better able to hit it. So now they're ready to hear. They've gone through some thinking. They've weighed the solids for a very particular reason. And you could do the same as well with the liquids too. What is matter? So now we get the formal definition. So there is a book on New Learn Alberta. If you click the eye of the outcome, there are supporting books like this. So the nature of matter I was looking at. Now it says here that solids and liquids have mass. I would substitute that to weight because we're not going to interchange, just saying. But other than that, this is a very, very good book about, matter, and that I would refer back to as well. So are solids matter? So based on the definition, can we say solids are matter? This is a thinking routine called claim, support, challenge. Claim is a statement to an answer to a question. I think solids are matter. The support is what tells us that. Well, in the book, it says it's anything that takes up space, that has volume. And we know that solid stays the same and it has shape. And when I weighed it, and it has weight. Then any questions, again, these thinking routines often have questions after. So then you can read and they can confirm their thinking with going back into the book now, solids are matter. So their brains are also primed when they're thinking, because now they're going to be, not so much checking out. What I would do then is a Freire model for solid and liquid, really kind of ensuring that they understand that it's a state of matter. Okay. And then some of the characteristics, it has a definite shape, it can change, then filling that in from what they've read. Get them to give you examples of solids and non-examples. So they've been really working and investigating, same thing with liquids and non-examples. Okay, again, now it says, what do we observe? And it's a little bit blank. You can put that under what did we learn, actually, because that is from the reading about matter. And how does this help us understand the ice cream story? When ice cream was liquid, it was a state of liquid state of matter. When it took up space, but it didn't hold the shape. It's the ice cream is a solid when it became ice cream, and because it had a definite shape. So you keep connecting it back to that particular phenomena. Now we get to the challenging piece of matter of being gas. Does it take up space and have mass? That's why I strategically was going this way, because they're getting used to having to prove whether or not a solid is matter and a liquid is matter. So they're going to have to do that with gas as well. So the experiment, and I've done this with grade sixes, and I would probably demonstrate this with grade three, but first demonstrate filling it with paper towel, a clear cup, and putting it in sideways, getting them to predict, if I put it in sideways, what do you think is going to happen? They'll say, oh, will the paper towel get wet? Oh, yes, it'll get wet. If I put it upside down, grade sixes said that it'll get wet. They're going to say the same thing, but it's not going to get wet because air is being trapped. But that's not the only thing, right? You want to kind of show a couple of things. And how do we demonstrate that air, like, about blowing up a balloon? Well, what's filling the balloon? Air. Because we can't see it, it still is around us. It's a gas. So this is another one I used in grade six, is having a meter stick. So you have to put the balloons on the same side of either end. And then, it's like a scale, and then you pop one. Why does it go down? Like once it kind of settles, it goes down towards the filled balloon because air has weight. So this is kind of claim support reasoning. What is the answer to the question? And our questions from the beginning is gas matter. Air as air matter. Air is matter. What's the observation? Air takes up space, so they can draw and label the diagram of where the air is and where the water was, and that it can be weighed and it has weight. Then they can say matter is anything. They can give the definition and then kind of connect it back to the definition. I would do a lot more guidance with this reasoning piece. I would get them to go off and do this and then work together on that particular piece. So now they're going to be looking at, now they know about matter itself. Now they're going to look at the change of state of matter with freezing and melting, and explore and observe how temperature affects matter. So you can read about solids turning into liquids. The term melting is being introduced. I think most students, well, you never know. We have a high percentage of ELL, so we should just really, level the playing field. When it freezes and melts, it's change of state. From a solid to a liquid, when it does that, it's melting, it's a change of state. So this investigation here is with juice. And so this is kind of a demonstration, but you can, the lesson talks about including students, or you can, bring in 2 frozen concentrate, get them to feel it, put a little scoop in and get them to feel it. What does it look like? What does it feel like? Getting them to describe it for you. You record it on a chart. And so the one that you have, you put the thermometer in. So the same thing with the water, they can describe it, and then you take the temperature of the water. You do this, you mix the frozen juice in with the liquid, mix it up, and the temperature will, take the temperature as well. So they have to tell you whether it's a solid or liquid. You're getting all of this from your students. How do we know? You're pushing for that evidence and that reasoning behind it. And then you go off and you fill it up and you put it in the freezer, and it goes back to becoming a solid again, and it changes state. And then the next day, you're going to get them to describe it, take the temperature, and get them to tell you whether it's a solid or liquid, and how do they know. So after that investigation, then you would do the learning summary table, because this is where they consolidate their learning and synthesize their learning. So what did we observe? Okay, and you might need to prompt them or put in sentence stems. What did we learn from that, what we observed? Okay, so that's getting them to really think about the small scale investigations as well, and then getting them to connect it back to the ice cream story. So cream starts out as a higher temperature, actually. Solids are a little bit cooler. So this is a little bit of depth here for them as well. Do all solids start to melt at the same temperature? So here we're connecting matter, like you see the curriculum connections here. So this is where a chocolate chip and beeswax, and you put one on the desk and they hold it in their hand after so long, and then they make some observations. So they're gonna predict, I predict the beeswax and chocolate will, because that's your sentence frame. Then they record their observation of the beeswax on the desk and the chocolate chip on the desk. And then through the closed hand, then they can take a temperature reading of that. However, how do you show that different solids melt at different times? I found this states of matter, and it walks through, I'll just play it just a little bit because we're running, I don't want to run out of time.
These 3 cones are made up of different substances. They're all frozen in a cabinet, which is at minus 25 degrees Celsius. Linseed oil on the left, water in the middle, and chocolate on.
Okay, so they go through and they show the temperature at the bottom so students can record it. And then answering the question, do all solids have the same melting point? No, they don't, because we saw that linseed, and then they can kind of reason that out, again, synthesizing their learning. So this again would go on to the learning summary table, but how does it connect back to our ice cream phenomena? The ice cream melted because the room is warmer than 0 degrees, and the liquid cream was warmer. Okay, so now students are going to have an opportunity to plan an investigation because, as you can see in the procedures, they actually should be. So how do you do that in grade 3? Well, we're going to do that with looking at examples of reversible and permanent changes caused by heating and cooling. And in the lesson, there is that you give a sort of an explanation first about what reversible and irreversible means, and you can work through that. Then you do a demonstration with popcorn. So the students would observe and describe the seeds and the crayon. And then this requires some heating. So a hot plate or something else that you can use in the classroom. So they describe the appearance before. Is it a solid or liquid before? The appearance after cooling. Is it a solid or liquid after? Based on the definition that was provided, this is a just-in-time teaching. So is it reversible or not? Irreversible is here, or permanent if you want to use that. So the students are working in partners, and they get to choose a substance that they want to test with their partner to decide whether or not it's reversible or permanent change. And they write down the substance. They will create the question, and then they have a prediction. This is the materials that are going to be needed. So this is the procedure. So heat the crayon or heat the gummy bear or whatever. So you can use a toaster, especially for the bread, but this may require like a heating plate. So that may need your help with that, or adult helper. And then the containers that are needed for it, and some safety as well. Okay, so then the next day, they're going to do the investigation, and then analyze their data and work through making conclusions. So they're going to, same thing as what they did when they observed when you demonstrated, they're going to describe the appearance, whether or not it's a solid or liquid, and then after, whether or not it's a solid or liquid, and is it reversible or permanent? And then work through their observations with sentence prompts, and then draw a picture of what happened when it was heated and cooled. Then you compile the data, so the testable material. So who did the gummy? Was it permanent or reversible change? So there should be a consensus among all the scientists in the classroom. And then you can provide sentence stems to them. So now that they kind of, instead of discussing, what did we observe, but then what did we learn? And then how does this connect to the ice cream story? So the sentence stems strips that you give them, that can be used by them to cut out and put together, which will be described in the lesson itself. So now in the scientific methods, which I thought was really interesting, it talks about data can be considered accurate when it comes from a trustworthy source, such as a scientific article. Peer-reviewed journals. That sounds so official. And so they're going to read more about they're going to collect more data through reading themselves instead of being read to about the ice cream story. And this was created by the American Chemical Society. So you can kind of have that conversation, who wrote it, is this, and it is it's an organization that, with chemical scientists belong to, and this is for children. So how you do this with your class is your context. So you may want to read through it with them first. You may want to gather students who are struggling readers and do a prefront with a guided reading with them beforehand. You know your context best and your reading strategies and how you would approach that. When I worked in a grade 2 classroom, they actually read this article. They were put in strategically with partners. The teacher had read through it beforehand. And what they went through was either a highlighter or a sticky, what I already know, what's information I already know, what's new information, sort of they've been doing that. And then what questions could I investigate? So what questions are coming up that I want to know more about that maybe we could investigate? They are supposed to be developing new questions. So when they come together and discuss the article, that goes on to the summary table as well. You would go through it as a class after and discuss it. That's in more detail in the lesson as well. I'm just highlighting some of the things that are happening in the lesson. And then, of course, synthesizing and summarizing that to how does it connect back to our ice cream story. Now, in this article, it talks about how ice cream has gas in it. So there's all 3 states in there, but it's very subtle and a little bit of that. So I just wanted to mention that as well. Finally, we're coming towards the end of our unit, and the students have been learning a lot and connecting it to their ice cream story and trying to figure out why does ice change from a solid to a liquid, and why does cream change from a liquid to a solid. So I kind of tried to make what it would look like. I took all the ones that were chopped up and put them together as a learning summary. You can keep that up and let them refer back to it. But what they're going to be given is they can be given what they had initially or be given new models. So there's a handout for this. And, they're given sentence stems. So that it says the ice cream model before it changed, right? So the ice that's in the bag and the liquid cream. Then after it changed state, what do you see? And then it talks about what to describe and has a little thermometer because when you make it, you should take it. It'll say take a temperature. There has been a single point rubric developed in consultation with our assessment consultant. And so you can use this to summatively assess for this part and towards the learning outcome. And now in your science methods, it says reflect on how conducting an investigation contributes to knowledge building. So why I asked you to keep their initial models is because you're going to give it back to them. I'm jumping. Before you give them the models, sorry about that, you should co-construct criteria with the students. So again, we were doing that before. So what do I want to see or hear? What should we be talking about when we talk about solids? When we describe them, their shape, their same with liquids, their volume, their shape, on their picture, right? Because they're able to hit the target if they know what should be included. Melting and freezing points, reversible or permanent changes. Where does this happen? Where do you see this? Because the ice cream is a reversible change because it goes from a solid to liquid and it can go back to a solid again. What change of states happen for both the ice and for the ice cream? So you're kind of giving them that guidance of what they, things or topics that they should include in their model when based on the rubric as well. Okay, so getting to, now this is an example of a student drawing of what it may look like. So students thinking during the process changes over a period of time, and that's what you'll see. Now, included also is I used to think, now I think. So that's where it's going to connect to reflecting on how an investigation contributes to knowledge building. So at the beginning, what did you think about ice cream? Well, here's your first model. Now look at what you think differently now, based on everything that we've gone through and learned. So that is supported in the research, as well as understanding that we're not going to get the correct answer from students right away, that this is an iterative process, but allowing students to engage in multiple explanations. If they continue to explain, they will revise their ideas, they will talk, they will write, and draw their way towards fluency and scientific accuracy. Okay, so that is all that we have today. And so I'm going to open it up for questions that you may have, but I also want to start with thanking you for coming and joining the live session today. I know it was a lot. I'm going to drop in the chat. Before I forget, I'm going to drop both the plan, which everything is linked. Okay. And I'm going to drop in the chat the slides from today's session as well, so you can use this in your classroom. Okay, so I'm going to give you guys, I'm going to just exit so I can move this little square. I have a secret number. I'm going to give you guys a couple minutes to just put that in the chat. Then you can receive this book. Okay, so dropping your number in the chat. I'm going to stop recording as well. So if you have any questions, I'm just going to put this up.